All right, what's up, everybody? So this video is intended to take you through how to conduct a couple t-tests within SPSS. I know that during the t-test module where we're introduced to the t-test broadly, we spoke about the one sample t-test, the independent samples t-test, and the dependent samples t-test. In this particular video, I'm going to take you through being able to conduct a one sample t-test and an independent sample t-test within SPSS. However, this particular data set doesn't have the necessary data required in order to run a dependent samples t-test. So we'll leave that one out of this particular analysis, which also means that it is left out of your the assignment that's associated with this particular content. So we'll just do a very brief recap of what the t-test is and what it is that it accomplishes. A little bit more about the specifics of the one sample versus independent samples versus dependent samples, and then we'll make our way through conducting the analyses within SPSS. So as a brief reminder, the t-test is a statistical analysis that is comparing the means of comparing means in order to determine if there is significant differences between data sets or between data. With the one sample t-test, that's where we are taking one particular sample and only one sample, hence the name one sample t-test, and we are comparing that against the population data. Okay. In the one sample t-test, you do need to have access to population data in order to be able to run your analysis. As we are working through the examples in SPSS with this video, I do have some sample data, or rather some population data, that I'm going to provide for you for the purpose of running this analysis, and then I'll show you where that comes into play in terms of your t-test assignment. With the independent samples t-test, we are comparing the means of two unrelated groups. And so that means we do need to be able to have two separate samples or rather we have two different samples of data. The groups are not to be understood as connected in the way that they are connected for dependent samples. In independent samples, they are unrelated groups, while in dependent samples, you're typically comparing groups at one point in time versus another point in time. And so that's the same group measured twice, where independent samples is two separate groups. Okay, so again, as a reminder, for this particular video, we're only going to be making our way through a one sample t-test and an independent samples t-test. So let's go ahead and get started. Notice here that I already have my data set available. You want to make sure that as you're becoming more familiar with SPSS, I'm not going to be taking you through the initial steps to get everything set up. There are separate videos that you can follow for that. At this point, I am working under the assumption that you've already learned how to upload your data into SPSS, that we're working with this 1K survey that we've already set up, right? We only needed to do it once. If you haven't yet done that, make sure you go do that. Okay. All right, so here we go. We're going to first conduct an analysis on the using the one sample t-test. So remember, one sample t-test comparing one sample that we have to population data. And the way that we're going to do this is using some information that I'm providing to you based off research that I've conducted. And you can actually confirm this. If you do a very quick Google search, I would ask you to search for the average age of a community college student. And if you type that into Google right now, chances are it should show you, the same data I got, which says that the average age of a community college student is 28 years old. Okay, so having that value, 28 years old, that represents our population data. Remember that the one sample is comparing our sample to the population. So what we're essentially going to work through SPSS to do is to say, is our sample significantly different from the population average of 28 years old? What we want to do when conducting any kind of analysis, the first step I'm always going to recommend is running a frequency distribution for the variables that you're using. In this case, because we're talking about comparing to the population age for community college students, we are working with our variable age. So we're going to come down to descriptive statistics, Click on frequencies. Notice that this is empty, as it should be. I haven't done any analyses yet. We'll go ahead and take this age variable, move it over to this variable window. We'll come into statistics. We'll ask SPSS to produce the mean, median, and mode. We'll also ask it to produce the standard deviation and the variance. We'll select continue, and then we'll select OK. Now, these steps of running a frequency distribution are good habit, really. That's ultimately what it is I'm trying to get you to understand about going through this process of, prior to running your statistical analysis, just take the extra step to run a frequency distribution of your variable. While we can work a little bit more confidently with this data set because we've already been introduced to it before, we've already worked with this data set, we can be confident that this data set is valid in the ways that we need it to be for the test that we're running. If you are working with a brand new data set, a data set that you've never used before, running a frequency distribution on the variables that you're going to be working with will help you get a sense not only of the kind of data that you have available to you, but it'll also give you a sense of how the data has been coded. It can give you a sense of, are there gaps in your data that you need to be mindful of when it comes to running your analysis? So be mindful of those things. And as part of that, we're building that habit by running our frequency distributions first. When we run our frequency distribution for this age variable, looking at this first statistics table, we see that there are 1,037 people who responded to this question. There are 30 people who are missing. We don't know why they're missing. This is kind of just emphasizing something I mentioned before. We don't know why they're missing. If they just skipped the answer, they didn't want to answer, whatever the reason is, they are missing, and they will remain as such. We're mostly concerned with these 1,037. If we were analyzing the missing data, we could then ask questions about how it is that we're collecting data. Are we being clear about what we're collecting? Are we providing enough context to people who are taking our survey as to the use of the data? Because sometimes people can be concerned about how it is that their data is going to be used. So if we provide enough context, are we able to limit the amount of people who are who do not want to share that information, right? So there are some things that we can do to help mitigate how many missing people we have. For this data set, this is just what we're working with. We have an average age of our sample of 22.55 years old. We have a median of 20. So if we organized everyone from youngest to oldest, the person right in the middle, and there's only one person right in the middle because the number of people who participated is an odd number. We have an odd number of scores, therefore only one person will be found right at the middle. That person is 20 years old. The mode, the most frequent age, is 19. Our standard deviation is 6.05 or 6.06, sorry. We also have this frequency table. We see that we have our youngest person at 12 years old and our oldest person at 60 years old. If we are working with a data set in perhaps a workplace situation where we are truly conducting this analysis to produce something from this that is going to be either used by stakeholders, then we might ask some questions about how it is that a 12-year-old managed to find their way into this data set. And really the question is more about, is it possible that someone erroneously recorded this 12 years old? While it is technically possible, I believe it's technically possible for a 12-year-old to be in a community college setting. How often does that happen? Is it possible that after we collected this data, did one of our data entry people mistakenly type 12? Maybe they misunderstood the number that was being recorded, or perhaps just a very simple kind of slip of their hand as they're recording the information. There could be some questions to ask. For what we're doing, we could just leave it alone, say, okay, we do have a 12-year-old in here, and just continue with our analysis like that. Okay, so remember that the focus is there a significant difference between our sample age, the sample mean age, versus the population mean age of a community college student? So we'll come up to this Analyze button. We'll come down to Compare Means. you're going to find that our one sample t-test is available, our independent samples t-test is available. Those are the two we're going to be working with for this particular video. We also have this paired samples t-test. That paired samples is another name for dependent samples. Remember, we're not going to be conducting one with this particular data set, but I want you to keep in mind that it's through this particular button, if you will. It's through this that we would be able to conduct that dependent samples.